Now let's look at solving simultaneous equations. To solve simultaneous equation is very simple. What we do is substitute the line into the curve. So right here we're given two equations. We have 2x plus y is equal to 1. If 2x plus y is equal to 1, I want you to make either x or y the subject, and so we can say, well then y is equal to 1 minus 2x. Now if y is equal to 1 minus 2x, what we're going to do is substitute. We're going to substitute y equal to 1 minus 2x into the curve. And this is the curve. So we're going to substitute y as 1 minus 2x into the curve. So what we're going to end up get then, we're going to have 4x squared plus y squared. Now we're substituting 1 minus 2x as y. So it becomes plus, this part becomes 1 minus 2x all squared. So this is our 1 minus 2x all squared. And we equate that to 5. All right. Now clearly just looking at this equation, it's going to reduce to a quadratic equation. So we're going to get 2 points of intersection. So what that just is telling us is that we have a curve and then we have some line and it passes through 2 points on the curve. That's all this question is telling us. All right. Because we can clearly see from a quadratic, we're going to get 2 points. Well, most likely we're going to get 2 points. All right. Or 2x values. So let's expand this out now. By expanding this out, we're going to get right here, we're going to have 4x squared. 4x squared. So we're going to have 4x squared plus, when I expand this right side, I'm going to have first term square plus twice the product of the 2 plus second term square. So it is plus 1 minus twice the product of the 2 is 4 times x plus second term square is 4x squared. So that part is now plus 4x squared, and that's equal to 5. So it's working out pretty good. All right. Now I can add the 4x squared and the 4x squared, and then I'm going to end up with 8x squared by grouping like terms. So I group the like terms to have 8x squared. And after I group the like terms, I get 8x squared minus 4x plus 1 is equal to 5. Now, instead of having the 5 over here, I'm going to bring it over here to get 1 minus 5. And 1 minus 5 is negative 4. And that's equal to 0. Now, after I have this equation now, I'm going to divide through by 4 to get 2x squared minus x minus 1. So I have 2x squared minus x minus 1. Now when I have 2x squared minus x minus 1 equal to 0, and I obtain this by dividing through by 2, we have this part now. All we need to do is just solve this quadratic equation. Now, I do not know if it's, let's see if it can be factorized, right? If it can be factorized. If it can be factorized, we're good. So let's see if we can factorize it. All right, we know that the two products to get, which two number when we times them, we get negative 2, but when we add them, we get negative 1. Yes, it can be factorized. Right, so this has to be 1 and 1. Now, because we have a minus right here, clearly it's a minus and a plus. So where now to get 2x squared, it has to be 2x times x. So where does the 2x go and where does x go? Now if I put 2x here, if I put the 2x here, I would get x times this is 2x squared. Yep, this should be the 2x. So I put the 2x here, and then I put the x here. Because x times 2x is 2x squared, then x times this is minus x, this times this is positive 2x. Okay, so now this part should actually be the plus, and this part should be the minus. Now this is fine. This times is 2x squared, this times is x, this times is minus 2x. Yes, nice. So now solving this equation, we get x is equal to 1. That's one possible solution. And the other possible solution is x is equal to negative a half. That's what we're getting now. Now, if x is equal to 1, what is that telling us about y? Well, since x is equal to 1, if we substitute 1 back into the function for y right here, we're going to say 1 minus 2 times 1. 1 minus 2 times 1. Always put in a calculator if you're not sure, if you're going to make a mistake. 1 minus 2 times 1, that's negative 1. Negative 1. And then we put negative a half back in right here. And so what we get is 1 minus 2 times negative a half. And that result is giving me 2. So right here I'm getting y is equal to 2. Now having obtained the x and the y values, all right, now I can just put them in coordinates form or write them as a ordered pair. And so I can just say the points of intersection are the points of intersection are, it's going to be 1, negative 1, and that looks like negative a half 2. Negative a half 2. And those are the points of intersection. All right. So that question takes care of itself. Very easy question. Simultaneous equation. Soft.